হাইব্ৰিডেশ্যনৰ যিটো কনচেপ্ট পঢ়াইছিলোঁ সেইটো কালি দিছিলোঁ, সেইটো বেছিক যিটো আছিলে এইটো হৈ গ'ল উইথ কণ্টিনিউৱেশ্যন ফ্ৰম ৱেৰ আই লেফ্ট য়েষ্টাৰডে। চ' হাইব্ৰিডাইজেশ্যন বুজাবলৈ আমি দেখিছিলোঁ যে এটা থিয়ৰী আফটাৰ লিউইছ ডট ষ্ট্ৰাকচাৰ, লিউইছে যেতিয়া বুজাইছিলে যে ডট দি পেলাই কেনেকৈ ইলেক্ট্ৰনৰ এটা আমি এৰেঞ্জমেণ্ট বুজিব পাৰোঁ, যেনেকৈ নাইট্ৰজেনত ভেলেন্স ইলেক্ট্ৰনত দুটা তিনিটা এনেকৈ বহুৱাই পেলাই আমি কি কৰিছিলোঁ, নাইট্ৰজেনত টোটেল 5টা থাকে। এনেকৈ লিউইছ ডট ষ্ট্ৰাকচাৰ আঁকিবলৈ শিকিছিলোঁ। তাৰপিছত দেখিলোঁ যে সিহঁতৰ এযোৰ লোন পেয়াৰ নাইট্ৰজেনত থাকি যায়, বাকী এইকেইটাই শ্বেয়াৰ কৰি এনেকৈ ডট ষ্ট্ৰাকচাৰটোত এনেকৈ কৰি এইকেইটাই ট্ৰিপুল বন্ড ফৰ্মেশ্যন কৰে। চ' দিছ ইজ লিউইছ ডট ষ্ট্ৰাকচাৰ। চ' VSEPR theory is a continuation or extension of the Lewis ideas. এই VSEPR theory ইউজ কৰি আমি পলিএটমিক যিবোৰ মলিকিউল আছে সেই মলিকিউলবোৰৰ শ্বেপ এণ্ড জিঅ'মেট্ৰি আমি কেনেকুৱা হয় সেইটো জানিব পাৰোঁ। চ' ইয়াত লিখা আছে VSEPR theory mainly helps to predict the shapes of polyatomic molecules. In this model, the position of the atom with electrons, both bone pair and lone pair, their positions are first given. First, we calculate the total electron pairs, then we calculate the lone pairs and bone pairs. After that, placing them at perfect places, their shape can be described from this. But one thing to be remembered here is that the shape is assigned excluding the lone pair position. Only the shape is assigned based on or giving importance to bonding electrons or bond pairs. So VSEPR theory mainly is given in order to know about the shape and geometry of polyatomic molecules and get some idea about what hybridization is responsible for what geometry or shape. So from this we get an idea of both the things, hybridization and geometry. So first in this theory, when any compound is given, any molecule is given, first we calculate the total electron pairs from this formula. Valence electron of center atom, say for nitrogen is 5 oxygen 6 carbon 4 in this way, plus monovalent atoms whose valence is 4, whose valence is 1. If atom with valency 1 is joined to the central metal atom, then that number of atoms is added in this, plus anionic charge, the amount of anionic charge, negative charge the molecule is containing. If it is neutral, then this and this both will be 0 or both have to be neglected, can be neglected, and negative of cationic charge. If the positive, then negative of that value divided by 2. Then total electron pairs is counted in the whole molecule. Then we calculate the number of bone pairs, same one number of bone pairs A বুলি কলো। এতিয়া total electron pair ইমানটোৰ যিটো ভ্যালু ওলাব ইয়াত, তাৰ পৰা যদি মই bone pair টো মাইনাস কৰি দিওঁ, rest of it will be lone pairs. So তেনেকৈ আমি lone pair bone pair উলিয়াই ললো from total electron pairs. Then আমি গম পালো যে lone pair টো ইয়াত বহুৱাই পেলাই চাব পাৰে existing and possibles হেৰিত চালো, possible ways. Then আমি চাব লাগিব যে যিমানে আমি বহুৱাব পাৰিম পসিবিলিটি আমি চালো, কিন্তু এটা কম্পাউন্ড বা মলিকুলাৰ শেপটো কেতিয়া এক্সিষ্ট হ'ব, যেতিয়া তাত ষ্টেবল হ'ব। ষ্টেবল হ'বলৈ গ'লে তাৰ ক্ষেত্ৰত কি হ'ব লাগিব, মিনিমাম ৰিপালচন থাকিব লাগিব, মিনিমাম ৰিপালচন। এতিয়া মিনিমাম ৰিপালচন হ'বলৈ হ'লে কি হ'ব লাগিব, আমি চাব লাগিব যে ৰিপালচন কাৰ কাৰ ক্ষেত্ৰত কি কি হয়। সেইটো কাৰণে এটা অৰ্ডাৰ আছে, লোন পেয়াৰ আৰু লোন পেয়াৰ সবতকে বেছি ৰিপালচন হয়, মানে লোন পেয়াৰ দুযোৰ যদি থাকে কিবা এটা মলিকুলত, আমি কেতিয়াও তাহাঁতক ওচৰত বহাব নোৱাৰোঁ, যিমান পাৰি দূৰত বহাব লাগিব। বিকজ তাহাঁতৰ ৰিপালচন যদি বেছি হয়, ওচৰত বহাও বেছি হ'ব, তেতিয়া বেছি হ'লে molecule to unstable hobo. Then lone pair, bone pair, then bone pair, bone pair. Okay, a priority order by repulsion order to follow kori ami lone pair, bone pair position to assign korim. Overall, a to kam kori pelai ami minimum repulsion jod ase hetuke stable boli dhori ami tar geometry and shape to dilim. So in this way, the whole VSEPR theory helps to predict or give the most exact shape and geometry of a molecule. So if we take one or two examples, then it will be clear to all. So as Lewis structure, Lewis theory helps to know about the homoatomic molecules like hydrogen, like carbon dioxide also we get to know from it. But complex molecules like IF7 say, ClO3 said, in these structures VSEPR theory helps us to predict the most exact structure. So it is just an extension of that Lewis theory. So let's take an example, say CH4. It is methane. So using VSEPR theory, we calculate TEP, total electron pairs. Total electron pair equal to total number of valence electron of the central atom. With a central atom to amar ki hoise carbon. Carbon with equal 4. Number of monovalent atoms. Valency is 1, hydrogen or 1. So 1 thaka valency ase. Jodi 1 thaka valency nai, let's say CO2 ase, that means 0. 4 plus 4 plus anionic charge it neutral, so nahe minus cationic charge neutral nahe. So 4 plus 4 divided by 2, 8 by 2 equal to 4. So when total electron pair is 4, so we write it as sp3. Means 4 means 1s, 3p, total 4. Total 4 electron pairs will contribute to sp3 hybridization. Now number of bone pairs. Bone pairs kiman? 4. Therefore lone pairs kiman hobe? 0, 0. So ami ete mane bone pair kita bahai sabo lage. So in case of sp3 hybridization and 4 bone pairs, the minimum repulsion is this. Hydrogen, 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 hydrogen. It is because in this compound only bone pair repulsion will be there. So bone pairs, if I place it like this, then it will not be minimum because in this is 90 degree. So here the bond angle is 109 degree 28 minute. This is called tetrahedral angle. So again, if you see that I can also increase from this angle. Yapao 8 angle ba moi increase ko paim. Karon ami repulsion jimane kom kintu jodi moi a angle to pa increase kori diu tetia onnota bondor logot a hydrogen logot moi 109 pa aru bahai dilu. তেতিয়া হলে কোনোবা দুটা হাইড্ৰোজেনৰ মাজত আকৌ এটো কমি যাব মানে এংগলটো কনস্ট্যান্ট নাথাকে এতিয়া এই হাইড্ৰোজেনটোৰ মাজত 109 ডিগ্ৰী 28 মিনিট আছে এই হাইড্ৰোজেনৰ মাজত সমানে আছে সো সমান হৈ আছে কিন্তু আৰু যদি মই বহাই দিও যেহলে বাকি কোনোবা দুটা মাজত কমি যাব that means two bone pairs will come together. This coming together of these bone pairs will again increase the repulsion, then the molecule will become destabilized. So when bone pairs is 4 and total electron pairs is 4, sp3 hybridization, the original structure or geometry is tetrahedral. So bone angle is this tetrahedral. Okay, from this we calculate this total electron pair, bone pairs, and assign its perfect shape and geometry. Now another confusion comes is I am saying shape geometry. So what is shape, what is geometry? So geometry is the exact shape of that molecule in which there is no repulsion, is there, only bone pair is there, no lone pair is there, only stable. In this way only it is stable. But after assigning it, if there is one lone pair or two lone pair, it will again go down, it will again change its shape. Then the exact geometry of the molecule is not fixed. Exact geometry will not be there in that molecule. So such compound in which there is repulsion, more repulsion, and after which the exact geometry of that compound is disturbed. So in these compounds, in such molecules or compounds, we assign its shape. So actual geometry may be sometime for 3 or more compounds, they may be tetrahedral, sp3 hybridization, but its shape is not tetrahedral for all sp3 hybridized molecules. So it depends on the number of lone pairs and bone pairs. Similarly, again, if we calculate another molecule, say NH3, so total electron pairs will be nitrogen 5, monovalent atoms is hydrogen 3, similarly for sp3 hybridization. So sp3 hybridization means we learned about it in the previous example. Methane is sp3 hybridization, 4 total electron pairs, then it will be what? Tetrahedral geometry. It is also geometry tetrahedral, but here number of bone pairs is not 4, it is 3, and number of lone pairs is 1. So in case of it, nitrogen, lone pair, hydrogen, hydrogen, hydrogen. So if in this compound I take it as tetrahedral, then it will be 109 degree, 28 minutes. But due to the presence of this lone pair of electrons, it repels the lone pairs, these lone pairs downwards. It curves downwards, so that to minimize the amount of repulsion, so that bone pair and lone pair remains at maximum position, possible maximum position. So it repels downwards to attain its stability. So its bond order decreases to 107 degree, approx 106 degree 51 minute. In some books it will be 106 degree 51 minute, can also be seen in some books, but approximately 107 degree, and its shape now becomes sp3 hybridization tetrahedral geometry, but due to this repulsion, its shape tetrahedral shape is disturbed and it becomes pyramidal. So why this geometry is disturbed? Because of the presence of this one lone pair of electrons, which is absent in case of the exact configuration, the exact structural molecule CH4. So in this way, VSEPR theory is used to assign the structures. Similarly, again, if I take another example, say PCl5, phosphorus pentachloride. So in case of it, phosphorus is nitrogen family, so it's again 5 valence electron, 3 total number of valence, total number of monovalent atoms 5 divided by 2 equal to 10 by 2 equal to 5. If it is 5, then sp3d, 4 means sp3, 5 means sp3d, 6 means sp3d2. Total number of electron pairs will be total number of hybrid orbitals, sp3d2. So sp3d, number of bone pairs equal to 5. So number of lone pairs will be 0. So it will be in exact geometry. When the total number of electron pairs is 5 and every number of bond pairs is also 5, then we have the geometry tetragonal bipyramidal. The trigonal bipyramidal means there is one trigonal plane, triangular plane. This triangular plane means this is a triangular plane, PCl3, and these three chlorine term positions are known as equatorial positions. So here the bond angle is 120 degrees between the equatorial. Below and above there are another two Cls. This angle is 90 degrees, 180 degrees. So these are called axial positions. Axial. And the angle between axial and equatorial is 90 degrees. So these are the angles. This is the geometry. This is, as the number of lone pairs is 0, there is no repulsion. As bond pair repulsion is only bond pair is present and bond pair repulsion is minimum. So the exact geometry of the compound is there for total electron pair 5. So it is trigonal bipyramidal. So similarly, we can assign everything based on this VSEPR theory and determine its shape. So this is PCl5, trigonal bipyramidal, PBP geometry বুলি কয় ইয়াক. গতিকে বন্ড এংগল এক্সিয়েল গিটাৰ মাজত 180 ডিগ্ৰী, এক্সিয়েল ইকুৱেটৰিয়েল মাজত 90 ডিগ্ৰী, ইকুৱেটৰিয়েল গিটাৰ পজিশ্যনৰ মাজত 120 ডিগ্ৰী থাকে. So ইয়াত তিনিখন প্লেন থাকে. এখন হৈ গ'ল এই ট্ৰাইগোনেল প্লেনখন ট্ৰাইংগুলাৰ. ইয়াৰ ওপৰত ক্লৰিনটো এনেকৈ থাকিব. এইটো এটা পিৰামিড আৰু এইখন হৈ গ'ল এটা পিৰামিড. So 3 প্লেনছ. এটা পিৰামিড, দুটা পিৰামিড ওপৰত এখন ফ্লেটকে ট্ৰাইংগুলাৰ প্লেন. গতিকে PCl5 done. Again another is ClF3. So here for chlorine, number of valence electron is 7, monovalent atoms is 3 divided by 2. 7 plus 3, 10 by 2 equal to 5. Again it is what? sp3d. Okay. Now number of bond pairs. 3. Number of lone pair 2, because 5 minus 3, total electron pair 5. Out of the 5 electron pairs, 3 are bond pairs, then other will be lone pairs. So we know that sp3 hybridization with 5 total electron pairs, geometry is what? Trigonal bipyramidal, means Cl F lone pair in this way, or Cl F there are 3 probabilities. First of all, we place these two lone pairs in complete opposite positions at 90 degree. Then we place it at one in axial, one in equatorial, and again we place both in equatorial, one axial. So lone pair interaction is LP interaction सबतके बेसी माने, then LP BP, then LP, then BP. Well, in this molecule, in the structure A, there is one lone pair interaction at what 120 degree. In B there is one lone pair interaction at 180 degree. In C there is one lone pair interaction at 180 degree. Oh sorry, 90 degree. So lone pair repulsion is minimum in B. From this lone pair interaction we get the structure B. Now again we go to lone pair bone pair. So here lone pair bone pair interaction is what? Lone pair bone pair. So there are one or two 90 degree lone pair repulsions, two and these two, total 4 90 degree lone LPBP repulsion 90 degree, and 2 120 degree lone pair bone pair. But here 1 2 3 4 6 90 degree LPBP. Clear? There is 6 90 degree. This will contribute to 3 lone pair bone pair repulsion and 90 degree. Again this lone pair will give 390 degree lone pair bone pair repulsion. Here lone pair bone pair repulsion is 90 degree. This with this 90 degree lone pair bone pair. This will be 90 degree. This will be 90 degree. 3 90 degree LPBP. And here is LP 180 degree. Array to LP 90 degree. LP to 120 degree. So A to my LP by A to G to बहुत कम. LP this is 90 degree. So यात मैं याते neglect कोई तो फैमिली यहाँ दुटा बीच भीतरत 120 180 उसर पहिले. So आमी चालू जे यार क्षेत्रत की ऐसे B क्षेत्रत 90 degree lone pair bone pair repulsion আছে. কিন্তু ইয়াৰ ক্ষেত্ৰত 4টা আছে 90 degree lone pair bone pair. দুটা 120 degree তাতকে কমি গ'ল. So কি হল যেহেতু ইয়াত lone pair bone pair repulsion তো ইয়াত বেছি আছে ইয়াত কম আছে. So এটো বেছি stable হ'ব compared to this. So হেতু কাৰণে আমি structure to more refined দিম এটো ClF3. গতিকে এটো structure যদি মই এটা simply লিখিবলৈ যাওঁ এটো structure টো এনেকুৱা হ'ব Cl F F F. But in the first slide only, in the start of the class I have written in a point that while placing all the electrons lone pairs and bone pairs we assign the exact shape or geometry of the molecule excluding the lone pair of electrons. So, and neglecting this, we write the structure. Then we see that it, although it is sp3d, means its geometry is trigonal bipyramidal only, but due to these lone pairs, we have to neglect it in its structure. So its shape is different. So its shape is just like T shape. So ClF3 shape is given as T shape with sp3d geometry. So similarly, you can try it for SF4, you can try it for IF7 using this VSEPR theory, calculating the total electron pairs, and seeing this lone pair repulsion, where it is maximum, where it is minimum, and after all, overall structure is given by in which there is minimum amount of repulsion. Then you do it by yourself which structure is more possible and which one can be neglected. So try it from yourself, and if you have any problem regarding it, please let me know in the comment section, or you can message me personally, so that I can again give some idea or do it for your understanding more clearly. So if you say it clearly, then only I can know. So I have cleared, I guess, most of your doubt on this VSEPR theory, those who are not clear. So please follow this video and share with most of your colleagues, most of your friends, so that they can also be benefited, and try to try to understand it from your own basic ideas and practice it, taking other examples also. So thank you for today, and I will continue with another video soon. Thank you.